The byte level layout of an Ethernet frame looks like this. We have a destination MAC, that's 48 bits, or 6 bytes in this picture, and the source is also, of course, a MAC that's 48 bits. There's a type field here that's just 1 byte that indicates that we're using IP, at least for everything that we care about here. And then there's the payload. The payload is always between 46 and 1500 bytes. So that 1500 should look familiar. That's a number that we've mentioned usually corresponds to MSS, the maximum segment size. And the 46 is a lower bound that means we have to send a certain amount of data because smaller things might get confused for noise. And then at the end we have that cyclic reentity check, or CRC, for the whole frame. So naturally, now that we're so many layers down, we have a much simpler layout to deal with. In IP, this payload is going to be the IP packet that we're sending inside of the Ethernet frame. When this frame goes over an actual wire, the physical level layout is the same thing as the conceptual layout, but we're going to start with 7 bytes that are 10, 10, 10, 10 and the purpose of that repeating pattern is to help the physical device sync, recognize an up and down pattern, and get in the right frequency with the incoming signal. The preamble ends when there's another number that's just like the ones that were repeated, but with an extra 1 bit at the end. So that's how an Ethernet device knows that it has found the preamble and it's found the byte that says that it's starting, and then we have the actual payload. Then after a given frame is sent, then there will be a little gap here to make sure that there's enough room to see the end of the frame and be ready for the next preamble.